Welcome my dear students. In this video we will be learning about coordinate bond. Alright. You have studied about electrovalent bond, you have studied about covalent bond, and now it's time to study about coordinate bond. See, I will just narrate a simple story to explain you about coordinate bond. Suppose there are two friends A and B. Alright. Both are going to write the exam. A has got its pencil box where it has its blue and black pen both. Alright. So it has everything with it. In the pencil box it has extra blue and black pen. Okay. Means the extra blue, extra black. When B goes to write exam, B forgot to take pencil box with him, all right, or her. So when they both meet at the exam center and B says that I don't have my pens to write exam, then A helps B and says, don't worry, I will give my extra black and blue pen to you. If I give my extra blue and black pen to you for writing exam, I will not face any problem, and your problem in doing so will get solved. B agreed. Alright. And then they both get bonded even more strongly than earlier. This story speaks about coordinate bond. A coordinate bond is formed between two atoms or two molecules or an atom and a molecule in such a way where one atom is electron rich. Electron rich means it has got an extra pair of electron. Extra pair of electron. Now what is the meaning of extra pair of electron? Extra pair of electron are none other than the lone pairs. Alright. And we know what are the lone pairs. Lone pairs are non-bonding electrons. That means it is those pair of electrons which are not involved in the bonding. They are extra pair of electron. So one atom should be electron rich. It should have a lone pair. Alright. And other atom is electron deficient. Deficient means it does not have proper electrons. Alright. So being electron deficient, this atom B is in need of electron pair. It needs electron pair. Alright. So when they both get bonded in such a way that A shares its lone pair with the B, means both the shared electrons are from one atom only. Clear? Then the bond so formed is called as coordinate bond. So if I define coordinate bond, so coordinate bond can be defined as a bond formed between two atoms in such a way that the electron pair involved in the sharing belongs to only one atom. That means one atom only shares its both electron with the other atom. Alright. Then the bond so formed will be called as coordinate bond. So coordinate bond is also based on sharing, just like covalent bond. Only the difference is that in the coordinate bond, this sharing is one-sided. That means only one atom shares its pair of electron with the other atom which is electron deficient. So we can also say that coordinate bond is a bond between an electron rich atom and an electron deficient atom. See, this sharing we always express the way I have written here. Once again, I'll show here the sharing of the electrons between A and B. A has got this lone pair, alright, and B is going to combine with A. This sharing is shown by the curved arrow, where the arrow is pointing towards B. This shows the coordinate bond. We can also show the sharing with the straight arrow as well. Straight arrow. Lone pair is given to B. So this bond so formed is called as coordinate bond. There is an important point to remember. When the electrons are being shared, these shared electrons, as we have studied in the electron dot structures of the covalent molecules, that the shared pair of electron after being shared comes at the center. So similarly, in this coordinate bond, the shared pair comes at the center. That means once the electrons are shared or coordinate bond is formed, then these electrons cannot be differentiated that whether they belong to A or they belong to B. In other words, I can say that once the coordinate bond is formed, then there is no difference between coordinate bond and covalent bond. Alright? Only the difference of coordinate and covalent bond is that covalent bond is formed by the mutual sharing of electron, but coordinate bond is formed by the sharing of electron, and the sharing is one-sided. Only one atom shares. But once the sharing is complete, then there is no difference between coordinate and covalent bond. Why? Because just like covalent bond, this lone pair after the sharing is completed comes at the center. I hope this introduction is clear to you. Now we are going to see the formation of two ions as the example of coordinate bond. The one ion is hydronium ion. Hydronium ion is written as H3O plus, hydronium ion. Okay. Now let us see how hydronium ion is being formed. Now hydronium ion is formed, dear students, by the combination of water and H plus. When water molecule comes in contact of H plus. Now this H plus can come in water through acids, or basically acids are only the source of H plus. Like if I take one example, that when HCl is dissolved in water, okay, it is dissolved in water, then it ionizes to give H plus and Cl minus. So in water, H plus comes from acid. So H plus once formed, it comes in contact of water, and then their combination give rise to the formation of hydronium ion. Now let us see how this hydronium ion is formed and why this is formed. See, what is H plus? If I ask about that, what is H plus? Then H plus is the positive ion which is formed when hydrogen loses an electron. So this H plus does not have any electron. Alright, already hydrogen does not contain any neutron, but it will have one proton. Okay, so H plus is none other than a proton. Now a proton cannot exist independently. So H plus cannot exist independently. That's the reason when H plus comes in contact of water, at that time it gets bonded with water and give rise to the formation of hydronium ion. Now let us see how H plus gets bonded with water. For that, I will just draw the electron dot structure of water. Directly electron dot I am drawing. So you know very well that in the structure of water, oxygen atom carries two lone pairs which are clearly seen here. One is this and one is this. These are what? These are two lone pairs. These lone pairs are non-bonding electrons. So due to the presence of the lone pairs, I can say that water is electron-rich compound. So when this electron-rich compound, I will draw once again, comes in contact of H plus, which needs stability. H plus which needs stability. Alright, because H plus is just a proton. Now to get the stability, H plus, if it gets 2 electrons anyway, so H plus will be able to get the duplet. So in order to get the stability in the form of duplet, it combines with water molecule in such a way that water shares its lone pair with the H plus. So when water molecule shares its lone pair with H plus, it gives rise to H3O plus. Now let us see the electron dot structure of H3O plus. H3O plus will be composed of HOH of water and bonded with H plus of this H plus which came from the acid. So first of all, you draw the electron dot structure of the water that way. And since this electron pair, this water has shared with the H plus, so this electron pair comes at the center. And overall positive charge. This positive charge indicates that one of the hydrogen is in the form of H plus. So this is this way hydronium ion is formed, and this is the electron dot structure of hydronium ion. Now let us see, my dear students, the electron dot structure of ammonium ion. This ammonium ion is formed when ammonia comes in contact of H plus. Okay. Now let us see the formation of ammonium ion via electron dot structure. So I will first of all form the electron dot structure of ammonia. Just have a look here. Ammonia, where nitrogen is bonded with 3 hydrogens and shared pair between nitrogen and hydrogen, and then nitrogen is left with a lone pair. So when H plus comes in contact of this ammonia molecule, now I have told you that H plus is none other than a proton. It can get stability when it gets the duplet. In order to get the duplet, ammonia shares the lone pair of the nitrogen with the H plus. I hope it is clear. So when it shares its lone pair with the H plus, then it results in the formation of ammonium ion, which will have the electron dot in this way. Look at the structure carefully, dear students. See here. This is the ammonia molecule part, and now the lone pair which is being shared with the H plus will come at the center. Alright, and overall positive charge, which is very, very important, which shows that one of the hydrogen is positively charged. So this way ammonium ion is formed. And the most important thing, just like covalent bond, coordinate bond is also directional. So we can show the formation of coordinate bond through the bond lines. See, ammonium ion, how it will be shown. In ammonium ion, this is ammonia, and it is forming coordinate bond with the hydrogen. One-sided sharing, as I told, we show it using a straight arrow which is pointing towards the donor atom. H is donor, pointing towards the donor atom with plus charge over it. Similarly, I will show the coordinate bond formation in the form of bond line in case of hydronium ion. In the hydronium ion also, dear students, H, single bond O, single bond H, this is water, and oxygen has shared its one lone pair with the hydrogen. So this straight arrow which is pointing towards the acceptor atom. I hope it is clear. Here, this pointing towards the acceptor atom, not the donor atom, sorry. Acceptor atom, that is hydrogen. So here, what is hydrogen? This is acceptor. It is accepting electron. And nitrogen is donor. So this arrow starts from the donor, ends to the acceptor. Similarly here, it points towards the acceptor and starts from the donor hydrogen with the positive over it. I hope this video is understood by you all.